All right, so this is Monday, the 1st of February, 2021. Let's see what's going on here before we get into that. So it was a year ago this week. It was like, it was last week. It was January 29th, I think, that Dr. Clevenger came to our class, and I used to do 2 or 3 guest speakers a month. And so she would come in, and I asked her to come in to talk about this. She was a virologist, like she studies the viruses and all. And so, and immunity and all that, immunologist. And so I've been talking to her, I said, you got to come talk to my class about this, because I was at a party, and then I said, you got to come talk to my class. So she did. And this is a year ago. And she told us, at the time, it was just this weird thing from China, and we were assured that it would never come here. If it would come to the United States, it'd be 1 or 2, maybe a dozen, then nip it in the bud. So, by the way, your government lies to you. I just want to let you know. So she said, and she kind of put the fear of God in us, and she didn't mean to, but in general, these things, there's no treatment for it. It's going to spread wild. It'll be in the United States in no time, and it'll shut us down. And so I was like, what? It was mind blowing. But at the time, we didn't realize it'd be so airborne. And so we thought, well, what we did the very next Monday is I bought all these wipes. Every table had a wipe. We'd wipe down the tables, wipe down the chairs. We thought, and then we started really getting our hands. We did this way before anybody else did, thinking that, okay, that'll keep us safe. Didn't even understand the idea, and she didn't either, that the mask was so important. We just felt like those people from China always wear a mask. Come on, what's wrong with you guys? And then we realize now, of course, heck, I wear 2 masks. But the point is that we, a little town here in Norman, Oklahoma, knew the dangers, and because we listened to science and we believed them, and we started taking precautions early. And I think back, if we had done that as a country, we wouldn't have 450,000 dead. Maybe be 100,000. I mean, but it wouldn't be near what it is now. So listen to the scientists. Okay, don't listen to politicians when it comes to science. They have an agenda. Okay, get it? They're probably, and I'm not just saying one particular party, but both of them sort of stretch the truth. Okay, let science be your guide, not politics, not any one person. Okay, speaking of that, here's some a person versus person. This is Isaac Newton versus Lyden. This is the cover of the Facebook group, and it's they're arguing over calculus. They weren't arguing over which calculus was right. They were arguing over who invented it, who was the first to invent it, as if it mattered, but I guess it did pride-wise. So Newton won the battles because he did destroy Leibniz's career. But Leibniz won the war because we use Leibniz notation now. Leibniz has been experiencing a renaissance in the last 30, 40 years. Speaking of Leibniz, this is his machine. Now, this is a reproduction built in 1923, but this is his machine he built in 1700. It's one of the world's first adding machines. And I don't know how he cranked the thing. I'm not sure how it works, but it looks pretty awesome. I'd love to see it work. But it was like a calculator. So way before Charles Babbage. And I told you that I was going to put this in there. So this has been added to the Facebook group, but kind of interesting. So Leibniz was a Renaissance man in many ways. It wasn't just physics or math. He was also philosophical, cultural, lot of things. Look up Leibniz. Okay, so the calendar here last week looked like this. I only put it up there so people were gone, or like I see Anthony's here, and Anthony is new. Well, he was here. No, there he is. Anthony, you need your icon. You have Anthony there, but when it goes to YouTube channel, it won't show anything. So you got to put a little icon like everybody else has on the screen. Come up with something. So anyway, so for Anthony or for anybody who missed last week, this is what we did last week. And this is it's on the Canvas on the homepage. This is this week. So a lot of this stuff doesn't apply to you. Joke Monday doesn't apply, although this does apply to you. Tonight by 7 p.m., it might be a little before that, I'll have a PDF up of test 4B, take home test 4B. Now tomorrow I'll have one available for the front porch. It'll be out there by 1 o'clock tomorrow. If you, 1 o'clock? Yeah, by 1 o'clock tomorrow, if you want to come by and pick it up, you don't want to print it off. But if you want to print it off, it's one page front and back. So that'll be available tonight by at least 7. This week, we do have the Ask Me Tutoring. It's Tuesday, Wednesday, Thursday night for those taking the ACT. And a couple students said, well, I don't really take the ACT because OU not really requiring it this year, OU, OSU. But if you want a scholarship, you got to take it. If you want to go out of state, if you want to actually make it, you have to take the SAT or ACT or something. If you're going to, they need, so it is still an important test, even if maybe for seniors, it may not be required to get to school. So consider doing here's our presentation. Consider doing that if you want. We have plenty of spaces left. And we'll do that Tuesday, Wednesday, Thursday night. Tomorrow we meet table 4. It doesn't really affect you. Maybe on those days I will meet one of you. Like we'll pick out one person and we'll ask them questions. Okay. Because I want to get to know people better. That's why we do it in meet table 4, so everybody gets to know each other in class. Wednesday is flex day. Now this does affect you. It does affect you because our times change. And we're not at 50 minutes, we're at 25 minutes. So Wednesday will be 25 minutes, 25 to 30 minutes. But it's the time on Wednesday for you all will be 12:55 to 1:25. Okay, 12:55 to 1:25. I will try and adhere to that. I don't get out, I get out at 11:45. I'll leave school at noon. So I'll have eaten lunch, I'll have time to eat lunch. So I'll be ready to go at 12:55 on Wednesdays. As long as they hold the schedule, we're going to go 12:55 to 1:25 on Wednesdays. We'll actually go from 1. We will go from 1 o'clock, 1 o'clock even. Okay, we'll go from 1 o'clock to 1:25. So just 25 minutes on Wednesdays. And it's important though, because Wednesday, we're going to go over the blue day on the test, which for you all is a problem, I realize. I'm going to grade 6 of the 9 problems. I've got 4 of them graded. I'll do 2 more, 1 tonight, 1 tomorrow night. 6 of the 9 problems. And they'll leave 3 for you to do during blue day. You've already done them, but I mean, you'll get a chance to work that problem again. So you have, some of you do, some of you turned it in, some still have the paper. You all have a PDF of it though. Okay, everyone has a PDF of the test 4A. So what we'll do for you guys, I'm thinking this for the first time, what we'll do is you all will either print that off or you'll use an iPad or something, but you will do these 3 problems we're going to do. You'll do them correctly. You don't really need blue pen. You'll do them correctly, and then you'll PDF them to me, the corrections. And then I'll give you, I'll grade your original test. And then if I see that you've given me your corrections, then I will give you back half the points you missed. Okay. Now, if you find that you watch me do it, and you can just sit and watch, you can watch Wednesday, and then Wednesday evening, I'll have a recording of it. Then you could then, fix your errors. But if you find that you did them right, you go, I'm not going to worry about it, then just don't. And just don't do anything, and you'll get the grade that you would normally get, okay, on the test. So I think we'll work it that way on blue days for you all. The rest of them will be in class. That's all we're going to do that day. Nothing new, just work on that blue day. Okay, ACT is Saturday. Feast and film, it's not really going to apply to you guys. Next 2 weeks. Next week is test week. This does apply to you on Monday night of the 8th, a week from today. There'll be a Zoom help session on the take-home test you're going to have available tonight. where I go over, where I just help. I'm not working the problem. Well, I'm helping, giving hints, that kind of stuff. Then you're going to submit your test on Tuesday night by midnight. And then we're going to do a video key. It will be available Wednesday morning. This is the week from Wednesday, and that's for the test. And also there'll be a day to get ready. So nothing new that day, just day to prepare for the test the next day on the 11th. The 11th, then for the in-class kids, that's a 300-point test. Yours will be, once again, you'll be kind of like this was back here. You'll be a Friday, Saturday. You'll get it like we did 4A. You'll get it on Friday, a PDF of it, and then you'll have till Saturday at 6 to turn it in. Now, there's still a few of you that never turned in your test 4A. It's not good. It's not a 0 yet, but it will be. It's become a 0. You're losing points every day you don't turn it in. So you need to get with me on that one, because there's really no grades. The only grade we have, you all have some grades, which are not in IC yet. I realize they're going to be in there this week. I'm getting my grades in. And then we start packet 5 on the 15th. We go 6 packets in a year. So this will be our 5th packet. Well, I know we 2, 8, 3. So really 2 and 3 were the same, but packet 5 then starts on the 15th of February. Okay, that's what's coming. Okay, we didn't do this. This is the dogs. We're going to give stamps for dogs today. There's that. And the stamps were these two problems. 4 and 5. You got 1 dog for 4, 1 dog for 5. You did them both. You got 2 dogs. You got an extra dog, an up dog. That's 3 dogs. And then you got an extra dog that they didn't know about, but I gave them an extra dog if they showed that their resultant was a different color. So some got 4 stamps today. Quite a few people, actually. Now, standing wave generator, I have this really cool, and I finally got it fixed. And I don't think I could show you guys it. It's at school now, headed at home. So I'll make a note to myself, get this. I'll get this tomorrow and I'll bring it and I'll show you guys. It's something I should have had out, but it didn't work. I finally got it fixed, but I should have had it when we were going over waves. But we'll go over waves again, or either late this week or early next week. So, and this is standing waves. This thing generates with string, it generates standing waves. It's kind of cool. We'll talk about that when I get that going tomorrow. Our Joke Monday. The Joke Monday this time is on Tiny Elvis. I'll put a link in the, I'll add a link. Hold it. Note to myself here to add the link. I'll add the link to this one because this actually, it's dumb. It's really dumb. But it's, ask your parents about Tiny Elvis. But it used to be a big thing. But it's kind of important to what we're going to talk about today. The idea of tiny, things tiny. Little d, Tiny Elvis. Okay. We'll get into that. There's the, this is us from last week. There's the equilibrant stuff. That's the official equilibrant key. And then this is what we talked about on Friday. We introduced the idea of fluxions in calculus. And so today, I'm going to show you where the derivative came from. What are the opening early thoughts of Newton and how he kind of helped. This isn't the only way. He did it all with also a theory, but this is probably the most practical approach I've ever seen. And this thing we're gonna do today, I saw a guy do it, a physicist. I was at a physics conference down in Houston about 20 years ago, and I watched a guy do it this way. I thought, oh, I wish I had been taught it that way. So this is what we're gonna do. Here's the main thing today. So you'll need a piece of paper out and divide, probably make this about a 1/4 page long. Don't make it in the tiny little corner, okay? Don't put it in a little corner. A 1/4 page, because you're gonna need some room on there. So I'm gonna pause it here and I'll give you room. Let me turn, okay. Okay, I'm back on the air because I wanted to, I didn't want to just leave all this off the recording. So the whole point to the rest of this time we're going to be together today is to show historically and also kind of the thinking wise how we get, using geometry and algebra, how we get from V bar to V. Now, we have used a trick in the past. We said that at the center of each interval, like between T1 and T2, at the center of each interval, this mid time We said at the midtime, the secant slope and tangent slopes are the same. And so we can cheat and say that algebra equals calculus, which is true, but it's not very practical. In fact, I'm tired. I don't know about you, but I'm tired of doing stegosaurus tails and do all those little right triangles. I mean, I like to color it all, but so Newton came up with a way to do it where you don't need to make those kind of secant ideas. You can go right to tangent. Because remember, Newton was trying to find a way to find the slope of the tangent line. Because if you find the slope of the tangent line, that is instantaneous velocity. So this is, remember, this is secant. This is secant slope, which is average, V bar. This is tangent slopes. We're gonna find out a way to do it without you having to do tangent slopes. Because tangent slopes, how many places does tangent cross a touch a curve? Secants touch curves in 2 places. But tangents, as you know, I know you're saying it, tangent touches curves in 1 spot. And how do you find the slope of a point? See the problem? So we're gonna figure out today how to find the slope of a point. Seems impossible. Okay, so tangent slope then is instantaneous. So this is algebra. This is calculus. And remember, back in Newton's day, algebra was sort of a new thing. It hadn't really been in Europe very long. Galileo didn't hardly use it. Okay, so here we go with our drawing. Now you need a ruler here. Let's go back to the old way at first. Let's find our slope, and between x1 and x2. So I take this, do my delta t, do my delta x, change in x, change in time, and the slope is the rise over the run. So slope, nothing new here, equals v bar, which equals delta x over delta t, right? Well, another way of saying that is change in x. So that's the same thing as saying, let me erase some of this. It might give me somewhere in here. That's the same thing as saying x2 minus x1 over t2 minus t1. So that's going to be our definition of secant slope. Okay. But in this essay on the test, you had to go from secant to tangent and from algebra to calculus. So here we go. I'm thinking like Newton now. So we start with the v bar equals delta x over delta t equals x2 minus x1 over t2 minus t1. All right. So now I'm going to do something that you're not going to like, some of you. V bar equals, I'm going to substitute in because, okay, I'll just do it and then see if you figure out. 1/2 at squared minus at2 squared minus 1/2 at1 squared all over t2 minus t1. Let me pause that you can blow this up so you can catch up. So that's the next move. Now, while you're writing that down, be thinking, how can you do that? And I have the chat open if you want to write any kind of question or comment. But how can you substitute in 1/2 at squared for x if it's a trio? Aha. Let's go back and look. If we go back, we're way back here. We go back to this. Boom. If we go back to this, way back when we were doing the tree of beautiful patterns, remember that? And then we have the trio here. In the trio, Remember we said that x is 1/2 a t squared. Now, we got that because of we derived it. We derived, go back to our equation sheet somewhere here. We derived the orange equations. As I remember, as a 10-step derivation. And that mark there. So here we go. So in the second orange, where's the derivation at? Do I have it? I don't know if I should include it. I didn't include the derivation. Oh, well. Yeah, no, I didn't. Anyway, here's the second orange. So in the second orange, there it is. X, that's delta, but it's, X here is 1/2 AT squared. If, that's if V naught equals 0. And if we go back and look at this, bear with me here. If we go back and look here, yeah. See right there at the beginning, see that slope? The initial slope right here is flat, so V naught is 0. So we can say, I'm thinking like Newton now, I can make that substitution. Okay, it's very important you see that. That's legal. Okay, now remember what Newton's trying to do is make that delta, that change in time, be extremely small to the point that it's infinitesimally small change. All right, so now we go here. All right, so maybe write this down, maybe not, but let's say that T1 is equal to 2.0 seconds and T2 is equal to 3.0 seconds. Would you agree that those aren't the same time? And so we have delta T equals to 1 second. Okay, now put that aside. Now, let's say T1 equals 2.00 seconds and T2 equals 2.01 seconds. So it's 100th of a second, about the limit of your phone, the 100th of a second that goes by. So delta T, it's a smaller delta. This delta is big. It's a smaller delta. That's not really a thing. I'm just being visual here. It's a smaller delta, but it's still decent sized delta, 0.02 seconds. Those aren't the same time. 2 and 2.01 are two different times. Okay, fair enough. Table that. Try it again. T equals, some of you don't like this at all, 2.000000 seconds. 1, 2, 3, 4, 5, 6, 7. Oh, heck. I'm going to go nano. Boom, boom. 9. T2 is 2.00000001 second. Well, those aren't the same times, right? I mean, delta T now, it's a really tiny delta, getting down to tiny Elvis size, really tiny delta, and that is now 1 nanosecond. That's the 1/1000th of a second in difference. We can actually measure that. Let's go to the limit of our measurements. It used to be a femtosecond, and a femtosecond is a thousandth of a picosecond. So a femtosecond, just as a side note, FS is 1 times 10 to the negative 15th seconds. And that's the order of how long it takes when a sodium atom comes close to a chlorine atom, and they're both neutral. You guys know from chemistry what happens, right? The sodium gives up its valence electron to the chlorine, and you produce table salt. It's an ionic bond. That happens on the order of femtoseconds. When sodium gives up its electron to chlorine to make table salt, it happens on femtosecond scale. But we can still measure that. And at one point, that was the lowest. Well, now we can go to a difference of a zaptosecond. Someone was looked it up in second. They put it on Facebook. And that is right now the limit of our measurement is 10 to the negative, I think they were saying something like 21st or something seconds for our little tiny delta t. Okay, 10 to the negative 21st. Okay, so I'm getting somewhere with this, I promise. So then one last one. T is 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'll throw a few more in there. 21, 22, 23, 24, 25. And T2 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is why we have scientific notation. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. There's a 1 there. Are these two the same number? Are they the same time?
Yes.
Yes. The answer is yes. I told you some of you are going to like this. Some of you aren't going to like this. Those are the same time. These are the same time. At that point, you say that the difference between them is infinitesimally small. There's no instrument we have. Well, I've now gone about 1,000 times more accurate. Maybe in 100 years we'll have one. But right now, there's no instrument we have that can measure that short amount of time. So we are way beyond the speed of light. I mean, this is crazy. So now we can say, now it's little dt. Now we can use little d. When that is infinitesimally small, we can say little d. Well, let's go back here now. With Newton, if he does that, he got the idea of, he figured out the idea. Okay. He figured out the idea of T's being really close, but if you're going to make T2 and T1 the same, what problem are you going to have here? Right? If T2 and T1 are the same.
It's going to be 0 at the bottom, right?
Right. You cannot divide. Let me turn this up. I can barely hear you. You cannot divide by 0. Can you guys hear me okay? Let me turn this off.
We can hear you good.
Okay, now I hear you better. So you can't divide by 0. But Newton's a smart guy. So take a look. Check this out. X equals, V bar, still V bar. I pull out the 1/2 A. I'm going to factor that out. That's T2 squared minus T1 squared, and divide that by T2 minus T1. Now, what can you do with that numerator that will help you on the ACT? I need an algebra identity here. There's an algebra identity that Newton then employed. And you'll need it. Say it again.
The bottom cancels out.
Well, but first you do something at the top. What can I do with the numerator? In other words, what is a squared minus b squared? It's not c squared, okay? I'm not talking Pythagorean theorem. That's a squared plus b squared. I'm saying, what is a squared minus b squared? What does that equal to?
Minus b.
Yes, we did that. Thank you. So there's your zoom point. We did this when we derived the third orange. A minus b times a plus b, called difference of squares. And by the way, this is very handy, not just for physics. This is used in math, and you will see it on an ACT. This is on ACT. I think I just got you another ACT point. ACT. Okay. So Newton used this. This is historically important in algebra because it led to calculus. So he said, okay, V bar then equals 1/2 A T2 minus T1 times T2 plus T1 divided by T2 minus T1. Aha! You see what I can do now, right? Goes away. Miranda said, they go away. And so this now becomes, I haven't done any calculus yet. I'm about to, but I haven't done any calculus yet. This now becomes V bar. Calculus is 90% algebra, 10% magic. We're about to show you the magic. V bar equals 1/2 A T2 plus T1. Okay. But now Newton, because of that little algebra trick, he no longer worries about dividing by 0. So now he is free to take the limit as the change in time goes to 0. When you do that and you have delta x over delta t, this becomes dx dt, which means you go from average to instantaneous. And at that point, you can now say that at that point, T1 and T2 essentially become the same. 1/2 A T plus T. It just becomes T. T1 and T2 are the same. I'm just going to call them T. They're for all intents and purposes indistinguishable because the difference is so small we can't measure it. So therefore we conclude they're the same number. A quadrillion and 1 is basically the same number as a quadrillion. You have to, okay, if your mind can't get around that, you're not going to make it higher level physics, or for that matter, chemistry. If you've ever done equilibrium constants, they say we're going to toss this part and make it go away. You can do that. It's legal mathematically to do that. Okay, when we're talking in the physics of infinity, that's what calculus is, you can do it. So that was that boom. That became boom calculus. At that point, algebra turned into calculus. When you take that limit, this is the magic sauce here. This is what allows you to go from algebra, this being algebra, to calculus. But you cannot violate a rule, as Newton knew. And so Newton was careful to use his algebra first, then not worry about the denominator. And so let me keep going then. We're getting to a big punchline. I'm down about, I still got time. I got plenty of time. Okay, so I don't want to lose this punchline. So that equals 1/2 A times 2t, essentially, right? Which is 1/2 times 2 is 1, and we have AT. And so we say that V equals AT. So we say that if X, now back to our drawing, if this is the trio, right? It's a trio, so it's true. And V naught equals 0. So if X equals 1/2 AT squared, then V equals AT. And that, my friends, is historically the beginning of the power rule. I kind of started talking about the power rule Friday, just barely. We were most talking history. But let's go back and look at right here. Let's go back and look at this sheet from Friday. And that's at the very end. I said, hey, look, let me quickly give you this. This is called the power rule. And I said I'd give you a little bit of history to it. That's what I'm doing right now. And so it turns out that that's one instance, and Newton found this to be true for other slopes. anytime you take that derivative, that's called a derivative. When you take a limit equal to 0, to stuff t goes to 0, that's the derivative. It gives you the slope, and it's the same. You do the same rule for anything. So if I have, if this is my function, say it's not just a trio, this is a quintet, and this is 6t to the 4th. If I have 6t to the 4th, I do the same thing. Here's the power rule. I bring the 4 down in front. This is what it shows up here as a power rule. You bring the 4 down, or the b, in this case, down in front. You subtract 1 from the b right here, and for the exponent. So 4t, 6t to the 4th becomes 4 times 6 is 24, and then 4 minus 1 is 3. 24t to the 3rd, and that is the slope. This shows that's this change. It's the function, the changing function of xt. Now, let me show you another practical aspect of this. Let's go back to this. And so take, for instance, the second orange. Make it orange here. So pretty much orange. So the second orange equation looks like this. No. The second orange equation is delta x equals v naught t plus 1/2 at squared. Now, take the derivative, do the power rule, and that's like saying a 1 right there, right? T to the 1st. So if I do that, according to Newton, I would have dx dt. Now, Newton would never say that. Newton just said x dot, and x dot meant velocity. So we'll talk about this more tomorrow. But Leibniz would say dx dt, Newton would say x dot equals velocity. And so now I do the power rule. I bring the 1 down in front. 1 times v naught is v naught. T to the 1 minus 1 is t to the 0 power. And what's anything to the 0 power?
1.
You know it's 1. So that goes away. Plus, now I do it for the 1/2. Bring the 2 down, I get at. And lo and behold, that is the first orange. So the second orange through calculus gives you the first orange. Now tomorrow we're going to learn the pink. And the pink, we're going to derive all 4 pink equations. Remember, to derive one equation using algebra, to derive the second orange equation took us 10 steps. To derive the third orange equation took us 10 steps. It was laborious. It took almost the whole time. But now with calculus, we're going to derive the 4 pink equations in 4 steps, 1 step per equation. That's how easy it is with calculus. That's why about 15 years ago, I said, I'm tired of messing with algebra. I'm going to teach these kids a little calculus. Because all of a sudden the floodgates are going to open up now. This class is going to take a whole nother level. We're going to go to a whole nother level now. Now we can talk calculus. And so, yeah, it's going to change your life. But this was the beginning. I mean, calculus will change your life. But it'll totally make every other math obsolete after you learn it. I mean, you'll use it. You use algebra. You'll never stop using algebra and geometry. But calculus will dominate your math from now on. Calculus and tensors. Okay, so all that was to get us to this idea of a power rule. And thus, okay, final thing here. Thus, we'll do one more thing. The power rule was born. I mean, I can teach a power rule to a 5th grader, but where it came from is a little bit, you know some geometry, you have to know some secants and tangents and all that kind of stuff. So it's worthy of your. This is a problem on the next test. You're going, what? It won't. You don't have this kind of detail, but we'll discuss it more later. Now I want to do this last thing before we adjourn here today. And let me show you how this works. So let's do number 1. We'll just do 1. Okay, we'll do 2 tomorrow. This is not homework. I want to give you the night off. Well, you all can go ahead and start in on the take-home test if you want, but otherwise just take the night off. So let's say the position function is, you can't read that, so I'll write it. X of t, you should have your paper though. X of t equals 2t cubed. Okay, well, so let's draw that function. We know it's a cubic function. Comes up something like, we're sketching it, something like that. And then we know dot, 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 dot down there. Okay, so that's x equals, x of t is 2t cubed. Okay, now, buffering. I'm now paying $6 a month to keep from buffering, and yet it still buffers. I'm a little irritated by that one. Okay. For the velocity then, v equals x dot, Newton style, which then now means the derivative. Take the power rule, bring the 3 down, I get 6t, take 1 away from the 3, 6t squared. Okay, that was it. That's all it took. Now let me plot that. You come up, and it's a bowl. So you dot, 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 dot that side, because that's imaginary time, negative time. Now let's do it again. A equals v dot, a derivative. Again, you just keep doing the derivative. This is called second derivative of the x, and we call that x double dot. And that equals, now we do it again. We bring the 2 down. We bring this, blow this up here. We bring this, how much time do I got? I'll stick a few minutes. We bring this 2, bring this 2 down in front. 2 times 6 is 12. Take 1 away from that 2. So you get, well, tomorrow we'll do a lot of practice problems too, but after a while you go, oh, that's all we're doing. 12t. I got kids that don't get a thing about physics, yet they get this. Okay, this is one thing they walk out in May going, okay, I can do the power rule. And then that equation will give us a graph like this. It's linear, it's very steep. Okay, and then we'll do it again to find jerk. Jerk now is a dot, which is v double dot, which is x triple dot. So if you want to call somebody a jerk, just call it x triple dot. They won't even know it. And that equals 12. 12, and this has units, meters per second, per second, per second. So that's just flat. So look at that. We plotted a quartet. Now tomorrow we'll make it a little more complicated. But ta-da! So we're using the power rule now. This class has changed. It'll speed things up. It'll make things easier. No longer will you have to draw that curve, do the stegosaurus tail, color in the right triangles. Oh my gosh. Then plot the v versus t, get the step function, find that mid times, plot that, and then go down and do that, do it. Now take the slope of the best fit line. That's your acceleration. You go, well, Mr. Askew, why don't we just do this in the first place? Because you need to understand where all this comes from. You know, I could teach you the power rule on day 1, but at that point, everything's black box. And you don't want to be black box. You're black box, you are susceptible to being deceived. We're trying to learn truth in this class. Everything from first principles. Okay, so let me stop sharing. And questions from the crowd. You can just turn your mic off. I'm going to go ahead and stop. I'll pause the recording. So let me pause it.